Hi guys, so my name is Labhesh Patel and I'm the CTO and Chief Scientist at Jumio Corporation. So the conversation that we are going to have today is about GDPR and how it is going to cause a massive change in the AI and the ML workflows that you might be running. So a little disclaimer out here, I am not a lawyer, but we have worked with a lot of lawyers because of the kind of workflows we run and the kind of personal data that we have to take care of, and we need to be compliant. We are going to talk about what we do at Jumio, just in the context, to give you a context of how all this works together with GDPR. We are going to be talking about some of the key elements of GDPR for probably the 0.5% of you who have not heard about GDPR. We are going to talk about some things that you can start doing that can help you move towards compliance. And I'm going to touch on compliant machine learning. This is something that we have started talking about. It's a new way of running your machine learning workflows to be more compliant to any of these regulations. So at Jumio, we are in the business of establishing trust online. So the usual methods of authentication, like passwords or SMS codes or knowledge-based authentications, they have proven to be vulnerable to attacks. And governments, regulators, enterprises, they are looking for new, secure, and robust ways of definitively establishing users' online identities. So our sweet spot is connecting a user's online and their offline identities. We use a mix of machine learning and human experts to quickly verify and authenticate an ID coming through our system. The process plugs into the currently existing workflows of enterprise processes and quickly tells the enterprise whether or not the incoming ID is fraudulent or not. Our other product, identity verification, is about establishing the presence of the actual human behind a transaction. So it tells the enterprise that, well, this person who is actually transacting is the person whose ID was just sent in. And we use biometrics, we use facial recognition, and a human element to compare a selfie to the picture which is present on your ID. So as you see, we are dealing with personal data up the wazoo. We have images, we have names, addresses, birth dates, all kinds of stuff. So this puts us right in the midst of GDPR conversations. So the essence of GDPR is about protecting the personal data of EU citizens. Now, this applies to any company that transacts with EU citizens. So even if the company's servers are based out of North America, if there are EU users that are using that service, and if that service requires in any way collecting of EU citizens' personal data, it will come under GDPR purview. And this goes into effect on May 25th, about a week from now, so hopefully everybody out here is already up and running with all the compliance measures. It is going to be really expensive to be in non-compliance with GDPR. There are two levels of fines. The lower level is 10 million euros, or 2% of your worldwide annual revenue. And the upper fine is 20 million euros, or 4% of the worldwide annual revenue, whichever is greater. So lower fines, they relate to data security standards or design faults within your system. There are certain things that you might not have gotten around to implementing. That will fall under the lower fine regime. Upper fines, they relate to specific infringement on data protection, data security rights of the data subjects. So for example, if companies are collecting a user's data, shipping it off to a different country or an international organization, that stuff would fall under the upper fine regime. Now, the level of fines are going to be dependent on the severity of the infringement. It's going to depend on the length, duration. It's not black and white, but what is black and white, that the ICO, it's not the ICO that you're thinking. This is the Information Commissioner's Office, they hired more than 200 people in the last few months, and this is all about getting ready for making sure that people comply and the enforcement of GDPR. The difference, the key distinction between controllers and processors within the GDPR regime is that controllers, they determine the purpose and the means of processing of the personal data. And the processors are the actual ones who process the personal data. Now, why is this important? So up to now, it was the controllers who had all the responsibility for adherence to regulation, and they were the ones who could have been fined for breaches. But with this coming in place, with GDPR, processors are also going to be liable for penalties. So now, controllers and processors are in this together. They have to work together. Controllers have to manage their processors very closely, and processors have to make sure that they also have all the infrastructure for compliance. So how can we start on the journey of getting GDPR compliance? Well, there are some things that we can start doing. Number one, data encryption. So having a baseline for data security is a good idea. If any one of you know about PCI DSS, that is a pretty good baseline for data security that can help you towards GDPR compliance from the data security side of things. Human review is an interesting one. There is a Recital 71 of GDPR states that some humans can opt out of completely automated workflows. So let's say you have a mortgage application machine learning system which comes back with a score for whether or not a user should be given credit. Well, you cannot just say that I'm denying you the mortgage application. The user has the right to come back and actually ask you and explain and challenge you on the decision. And it cannot be, the answer cannot be, well, the FC7 layer of my ComNet says that the weights are this, and so that's why you got denied. You have to give a human interpretable answer. So if you have a human in the loop system where there is a human is touching the workflow somewhere, you are closer to compliance. Data retention, both the controllers and processors need to have infrastructure in place so that if for some technical reason your system goes down, you can respond very quickly, get the user data back online very quickly, and you need to have a configurable data retention policy. So a user should be able to come into your system and say that, well, delete my data after X amount of time, and your system needs to be able to comply with that. GDPR is very, very strict about the breach notification part of it. So the idea out here is that there is a concept of personal data breach within the new regulation. And the personal data breach, this concept is much wider than the usual types of breach that we talk about. Within this regulation, a personal data breach can happen just by unauthorized access to the data. And here also, having a baseline data security standard such as PCI helps you along a lot, because then you get a lot of the encryption at rest, encryption during transit, logging, monitoring, a lot of these things are already in place. If not, you might have to do that because that will minimize your chance for having a data breach. And then compliant machine learning. GDPR does not specifically talk about machine learning, which is very annoying, but they have these articles like Article 13, which is the right of erasure, and Recital 71, which is the right to explanation, which kind of gives you the hint as to what the spirit of GDPR is. So with compliant machine learning, you want to make sure that all the different steps within the machine learning workflow are compliant to the spirit of GDPR. Basically, this is something that we are working towards. And compliant machine learning is all about building in data privacy and security at every stage of the process, starting from data acquisition, tagging, processing, model training, deployment, evaluation, that entire pipeline. How do you look at each of these steps with the lens of data privacy and security? Again, Article 13, which is the right to explanation, makes it difficult because you have to make sure that your workflows are interpretable. The right to disappear, which is Article 17, now your machine learning algorithms need to be flexible enough that if somebody in the system says that, okay, forget me, then you have to have the infrastructure in place so that their memory, residual memory, is completely removed from your machine learning pipeline. Data minimization is another principle that GDPR talks about. And the entire idea out here is the footprint of your data should be as small as possible. So my personal data should not be lingering around in your servers for longer than it is absolutely necessary. So if you're training computer vision model, and it takes several weeks to do that, and you have to run multiple epochs on the data, then you have to really think about how to do that and whether you have the right consent from the user to do that. And you cannot really commingle data from multiple customers. So this is a very key point, and introduces a lot of friction in the current way of doing things. So for example, let's say you are a data processor and you have a few controllers as your customers. So traditionally, what you were able to do is you will get data from all the controllers, and you can train a machine learning model or an AI model which aggregates all this data, and now you have one model, and you'll open up a REST API, maybe you have it on TF serving or something, and you'll be serving out that model to various customers. Well, now it becomes tricky to do that because the controllers, the end users of controller A, have given right to controller A that it should be the data can may be used for improving the product which is being provided by controller A. So now this user their data cannot be used to improve the product for controller B, which is what would happen if the processor were aggregating all the data. So now you can imagine for each of the steps, whether it be the data capture step, the pre-processing step, training the model step, testing, evaluation, everything, you have to figure out a way of doing it n times for your different controllers. And if you do not have a huge data velocity from your controllers, from some specific customers, then guess what? Their models are not going to be that robust. So this introduces a lot of friction in the current ways of doing things. And within each step, if we look at the step of data capture, what is allowed is if I create a model on controller A, if I have some human relevant insights, I can hard code those insights into model B. Let's say I train a decision tree on controller A, and I find that there is this one particular attribute which reduces entropy the most. Now I can, if as a human, I know that, I can go over to the other table where I'm doing model B and explicitly code in that attribute and be done with it. If I'm using human as a conduit for passing this information, I'm fine. I cannot just take the model and start with that model on the second one. You cannot really do that. So human insights can be transferred. And when you're doing the pre-processing, every single step of, let's say you have a human workforce which helps you in tagging data. Now, when the data is being transported to their workstations, it needs to be encrypted. The tags that they come up with, they need to go into an encrypted store. The channels all need to be encrypted. end to end, we want to minimize the data breach, because if this human just takes a picture of this particular personal data on their screen and tweets about it, well, you are in breach. And you need to make sure that this doesn't happen. So this might require physical security, frisking of these people before they go ahead and start tagging data. So a lot more rigor needs to be put in place. Model training, again, we usually, machine learning, you will run multiple epochs over your data, and between those epochs, the data is just sitting on disk. You need to make sure that that process is encrypted. And if it is coming from the cloud, if you have a cloud server where the data is getting stored, you need to make sure that the pipes are encrypted. So you just need to start thinking about privacy and security at each of these steps. Encrypting your API keys, et cetera, is very important too. So in summary, the way you want to get started in the journey for moving towards compliance is start with a baseline security measure like PCI DSS or some security standard. You might want to have security audits, pen testing, encryption audits, independently verified audits. Human-in-the-loop workflows are probably good, because at least some of these articles that talk about explanation and interpretability of whatever you're talking about, you are able to provide that in time. Also, when somebody comes with a specific request that why is this decision taken, you don't have infinite time to come back. So unless you have a workflow in place that the reply can come back within a few days, that might cause problems. We talked about compliant machine learning, where looking at every step and building in data security and protection within each step can help you get compliant. Data retention, you want to have an independently audited data retention policy where it should be configurable. Users should be able to come into the system and say, well, I don't want you to keep my data, and you should comply with that request. And breach notification, where you have to, once you find out about a breach, you have to notify the appropriate supervisory authorities and the data subjects who are actually affected within 72 hours. So in summary, GDPR is here now, and I think there's going to be a mad scramble to get compliant, but in the long run, I think it's good because this will create an environment where users will actually feel empowered. And last but not least, I'm hiring. So if you guys are into deep learning, computer vision, AI, go to Jumio.com, drop us a line. We are hiring all over the world. Thanks a lot.